Hello. In this video, we look at the dot product's connection to the angle between two vectors. It's very surprising. This particular slide, we're going to show the connection, then we'll do some calculations in subsequent slides. So first up, we have two vectors, u and v, okay? And then the angle between them will be the angle that's made when you put their initial points on top of each other, okay? To figure out its connection to the dot product, what we'll do is we'll complete the triangle. Remember how we had parallelogram that is defined by the two vectors, one diagonal being the sum that comes from the initial points to the terminal points, and the other diagonal being the difference. And so this here is the other diagonal. It's v minus u. And what we're going to consider is v minus u's magnitude. Well, actually, v minus u's magnitude squared. So in the last video, we looked at properties of the dot product, and we said that when you dot a vector with itself, you'll get the vector's magnitude squared. And so that's what we're looking at here. The vector v minus u dotted with itself equal to its magnitude squared. What we're going to do with the right-hand side is FOIL it out. V dot v, v dot minus u dot v, and minus u dot minus u, which will end up being u dot u. When there's negatives, you can pull them out front. One of the other properties is that if there's any kind of a constant, it can go out front, it can go on either one, but it just doesn't go on both. And so the negative v dot u and the negative u dot v would be the same as if it was on the other one. I put the v dot u in red, okay, because it's another property is that the dot product is commutative. We could switch the order on them. So I'm going to trade in the v dot u that's in red for u dot v. That way I can combine the two middle terms, like in O and I from FOIL, combine the two middle terms. Here we are. If we have minus 2u dot v, if we have minus u dot v and minus u dot v, what we get is minus 2 u dot v. When it comes to these other guys, the vector v is dotted with itself, and the vector u is dotted with itself. And so those are the magnitudes of those guys squared. So let's put them next to each other. We have the magnitude of v squared plus the magnitude of u squared minus 2 times the dot product between u and v. Still is not connected to angle yet. This is just something in general about vectors being the side, representing the sides of triangles. Nothing here yet. But let's go over to the next half of the slide and let's look at a common occurrence in a geometry class called the law of cosines that relates the sides of the three sides of a triangle to one of the angles. So we have A and B, the sides A and B creating an angle theta. Opposite that angle is called side C. And law of cosine says that the side that's opposite the angle squared is equal to the sum of the squares of the other two sides minus 2 times the product of the other two sides times the cosine of the angle between them. Now let's use that in relation to the drawing that's on the left with the vectors. We can't just put vectors in here though, we got to put magnitudes. And so playing the role of C is the v minus u, playing the role of A is u, and playing the role of B is v. So take that law of cosine statement, replace the letters now with the vectors, with the magnitude of the vectors. So on the left-hand side, we have the magnitude of v minus u squared. On the right-hand side, we'll have the magnitude of u squared plus the magnitude of v squared minus 2 times the product of the magnitudes of u and v times the cosine of the angle between them. Okay, great. That's just from law of cosines. That is a fact. And so now what we do is we compare our two sides. They each have a representation of what the magnitude of v minus u squared is. Well, the magnitude of v minus u quantity squared. That magnitude squared can be represented with the left-hand side and also with this right-hand side. And so those two things must then be equal to each other. Okay. well, both of these have the magnitude of u in them squared and the magnitude of v squared. After you get rid of that, then you're left with the -2 that's on both sides of the equals. So let's get rid of that. And there we have our statement. The fact that on the left-hand side, the dot product, u dot v, is equal to the product of u, the product of the magnitude of u and v, times the cosine of theta. So the product of the magnitudes times the cosine of the angle is equal to the dot product. You know, dot product is just nice, easy calculation. No trouble there. So then its connection to cosine theta is here. We can take this equation and solve it for cosine theta and find out that the cosine of the angle between two vectors u and v can be found by taking the dot product between those two vectors and taking the product of the magnitudes of those two vectors and dividing by that. All right, that's great. All right, now let's go further. When we talk about the angle between two vectors, it must be an angle that's between 0 and pi. And so if you have the angle, you know, being between 0 and 90, that's called an acute angle. Between 90 and 180, that is a obtuse angle. An obtuse angle, if it's exactly equal to 90, that's a right angle. If it's exactly equal to 180 or pi, that's a straight angle. If the angle goes beyond that, then you just flip, you know, look at it from the other perspective, and all angles must be between 0 and pi when it comes to the angle between the two vectors. Okay. All right, great. That other form of the equation for the dot product is that we can take the dot product and set it equal to the product of the magnitudes times the cosine of the angle between them. Let's look at this closely. We have vector u and we have vector v. They're non-zero vectors, okay? And let's assume they're non-zero vectors. And so then when it comes to finding their magnitudes, then it won't be 0, it'll be something positive. So you have the product of three things on the right-hand side. And the two guys that are magnitudes, those are positive. And so it's very possible for a dot product to come up with a negative sign. Of course, you're just multiplying and adding. And so the sine of the dot product is connected to the cosine of the angle between the two vectors, the SIGN sign. The sine, SIGN, of the dot product and the cosine of the angle, those guys match. The sine matches at least. And you can use that to know what type of angle you have. Okay, when you are between 0 and pi over 2, you're called an acute angle, right? We saw the picture last slide. Well then, for all angles that are acute, the cosine of those angles is positive. Any angle that's from 0 to 90, any angle in the first quadrant has a positive cosine. So that means then, since the cosine is positive, then the dot product is positive. Okay, they're tied together by this formula. If you go past 90 and you're between 90 and 180, or pi and pi over 2, the type of angle is called an obtuse angle. We saw the picture on the last slide. For those angles, when you flip to the second quadrant, you'll have a negative cosine. And so the dot product for those types of angles will always be negative. Okay. And then finally, this is the big reveal, I guess. If you're exactly equal to 90 degrees, if you're a right angle, the cosine of 90, the cosine of pi over 2 is equal to 0. And if you're equal to 0 on the right-hand side, you'll be equal to 0 on the left-hand side. And so, if you have a 0 dot product, it's the angles, the angle between the vectors is equal to 90. The vectors are meeting at a right angle, and the word we tag to that isn't perpendicular like we do for lines. The word we tag for that is orthogonal. The vectors are orthogonal to each other. Okay? When the dot product is equal to 0. All right, great. Well, let's just do a quick calculation about the angle between these two vectors. We have the formula. The dot product between these two vectors we calculated already to be Oh, no, we didn't. Negative 8 is the dot product. We take a negative 12, a 0, and a 4. That's a negative 8. The magnitude of u is 9 plus 1 plus 4, so 14 underneath the radical. The magnitude of v is 16 plus 4, so 20 underneath the radical. But we should probably write that as 2 root 5. So then we have all the three numbers we need for the dot product. I mean, for the angle between the vectors. The cosine of that angle is negative 8 over 2 rad 70. If you want to, you can cancel that and make it negative 4 over rad 70. If you don't want to deal with the rads in the denominator, if you want to rationalize, you can do that. Multiply top and bottom by rad 70. And then you could do a little more canceling because the rad 70 in the bottom times rad 70, they become 70. And then they both are even, the 70 and the 4. So it turns out then that the cosine of the angle between these two vectors is negative 2 root 70 over 35. Or that theta is the cosine inverse of that. Okay. All right, great. So that's the end of this video. Sorry, I went a little longer than normal. I just wanted to connect cosine of the angle between two vectors to the dot product. We established a formula, and we did it one example, and we looked at some properties about acute and obtuse and right angles. And the main takeaway was that when your dot product is equal to 0, the angle between the vectors is 90, or pi over 2. My name is Nakia. Remember, thank you for watching this video. If you have any questions, please comment down below or reach out to me. Like and subscribe, and I'll be sure to see you in the next video. Thanks.